Okay, to finish up the last part of this lecture, we've looked at the algebra of our exponential functions. We've looked at the derivative, and so of course to finish up we'll be looking at the integral of e to the x. And not just e to the x, but really any function for my exponent, so e to the 2x. So the integral of e to the x, you're going to like this one, is e to the x plus c. It gets a little bit more complicated when we have an exponent here that's just not x. If we have an exponent here that's any function of x and we represent that with the u, the integral of e to the u is e to the u plus c. But of course I have to use my u substitution here to make sure that I have all of the u and the du in place. So let's go ahead and look at a few examples here. First one we want to look at is a nice easy one. Let's look at e to the negative 2x dx. U substitution, u equals negative 2x. du is a negative 2 dx. So we see that we need a negative 2 on the inside, so I have to compensate with a negative 1/2 on the outside. And then, like I said, we need this negative 2 on the inside. And what this simplifies to then is negative 1/2 integral e to the u du. And of course from up above we saw that this was just the integral of e to the u then. But u in this case I have to back substitute was negative 2x plus c. So there's my solution. The integral of e to the negative 2x is negative 1/2 e to the negative 2x. Now remember, you can always check these by taking the derivative of your solution. So let's go ahead and take the derivative of this expression. Drag the negative 1/2 along. The derivative of e to the u is e to the u times the derivative of negative 2x in this case, which is negative 2. The derivative of a constant is 0. Negative times a negative is a positive. The 2's cancel. And I'm left with e to the negative 2x, which was my original integrand. So this does check. Remember, you can check all your solutions here. Okay, on our next one, let's go ahead and involve a trig function as well. Let's look at e to the x times the cosine of e to the x. Nice little u substitution here again. We know the integral of the cosine of u, so if we let u equal e to the x, du is just then e to the x dx, which I have. I just need to rearrange things a little bit. So this is equal to cosine of e to the x, and then rearranging e to the x dx. This piece becomes my du, and of course this was already u, so this is just the cosine of u du. Now this one is one that we recognize for sure. The integral of the cosine of u du is equal to the sine of u, but we have to back substitute. U in this case was e to the x plus c. And again, you can check your answers for these as well. Let's go ahead and look at one last one for an example. The integral of e to the x times e to the 2x plus 1 quantity squared dx. Now when we look at this, you might be tempted to let u equal e to the 2x plus 1, but my du would be 2e to the 2x, and I don't have an e to the 2x, I just have an e to the x, so I'm kind of stuck here a little bit unless I do some rewriting. So let's rewrite this. Instead of e to the 2x, let's write this as e to the x quantity squared plus 1. Okay, and then I think everything will work pretty slick here. In this case, let's let u equal e to the x, and of course du is e to the x dx. I have this e to the x dx, so I have that in place. So when I rewrite this, this piece right here becomes u squared plus 1 quantity squared, and then du. Well, to integrate this, I can't use another u substitution like a w substitution, because I don't have a 2u out front if I let my w equal u squared plus 1. So I need to expand this. If I expand this, I get u to the 4th plus 2u squared plus 1 du. And of course integrating this isn't bad. U to the 5th over 5 using the good old power rule plus 2/3 u cubed plus u. Of course we need to back substitute. U was equal to e to the x, so I get e to the 5x over 5 plus 2e to the 3x over 3 plus e to the x. I don't want to do plus c quite yet. We need to simplify this a little bit. First of all, we could find a common denominator, and then we could also factor on an e to the x. So common denominator would be 15, so I'd have 3e to the 5x plus 10e to the 3x plus 15e to the x over 15. Working from here, looks like we could pull out an e to the x over 15, and we'll be left with 3e to the 4x plus 10e to the 2x plus 15 plus c for my constant of integration. So there's my simplified form, a little bit easier to work with. So hopefully the review part of this, the rules of exponents and whatnot, was very familiar to you because you've been seeing those rules for many years. The derivative and the integral are new. In the next section, in section 7.2, we're going to be looking at the inverse function of e to the x, and then eventually getting into logarithms and their derivatives in further sections.